So you're welcome to T.M.C. My name is Mega, and today we're also going to go deeper into how we can apply the rules of differentiation in the journey of calculus. So stay tuned and like the video and also share to your friends. Now, we're going to be talking about the power rule. Like I did mention, every child that is born into this world has to know how to apply the power rule. And it is very, very simple. Now look at this now. If we have y to be an arbitrary function, so that y is equal to ax raised to the power of n. Now, from the first principles of differentiation, the power rule was invented such that the derivative of y, which is a function of a variable x, in this case, a and n are just arbitrary constants, but the variables that we have here, the only variable that changes here is given by x. So the derivative of y with respect to x is given by the y dx, according to the power rule, is given by a times, in this case, the power here is n. So the power n comes down to multiply the base. That is going to give us n times x raised to the power of n minus 1. So this is just how to apply the power rule. So we have that the y dx is equal to a times nx raised to the power of n minus 1. So it implies that in applying the power rule, the only operations you need here is just multiplication and subtraction by 1. Simple as it is. So let us look at this example. How do we apply the derivative? How do we apply the first principle in finding the derivative of any given function? So let us say, for example, we have y is equal to minus 2x raised to the power of 3. Now, the y dx. Why is it the y dx? It is based on the fact that we have a dependent variable y, which is a function of x. So we are differentiating y with respect to the independent variable. So to find the derivative of y, take note that y is a function of x. So y is a dependent variable and x is the independent variable. So the derivative of y with respect to the independent variable x is going to be given by, in this case, minus 2 is multiplying x. It's just a number. You can just keep it there. Minus 2 times, in this case, applying the rule, the power here is 3. It has to come down to multiply the base. So that is going to be given by 3x raised to the power of 3. Then the second operation after multiplication is subtraction. So we are removing 1 from the power. Therefore, it implies that the y dx is equal to minus 6x raised to the power of 2. This is just the whole idea. Now let's look at another example. Let's say we have y is equal to 2x raised to the power of 3 plus 4x raised to the power of 2 minus 3x plus 4. Now, in this case, the derivative of this function, the y, differentiating y with respect to the variable here, the only variable here is just this function y is said to be a function of one variable. So in this case, we have the y, the x, is equal to the derivative of this 2x raised to the power of 3 is given by 2 times 3x raised to the power of 3 minus 1 plus 4 times 2x raised to the power of 2 minus 1 minus 3 times, the question is, you have x here. What is the power of x? Remember that anything raised to the power, if anything raised to the power of 1 is going to give us that anything. So x raised to the power of 1 remains x. So it means that the power of this x here is 1. So here we are having here to be given by the derivative of 3x to the power of 1 is going to give us 3 times 1 times x raised to the power of 1 minus 1. Then what becomes of the derivative of 4? The derivative of 4 is a constant. So if we differentiate 4, it ought to give us 0. Why is it 0? Remember that 4 can be rewritten as the product of two numbers. So we can rewrite 4 to be given as 4 times 1. From the laws of indices, we know that anything raised to the power of 0 is going to give us 1. So since we are working in terms of the variable x here, we can express 4 algebraically in terms of x. So we can rewrite this one as x raised to the power of 0, which is 4x raised to the power of 0. Because x raised to the power of 0 is 1. 1 times 4 is 4. So this implies that 4 is the same thing as 4x raised to the power of 0. So how do we differentiate 4x raised to the power of 0? Applying the power rule. All we just have to do, the derivative of this is going to give us 4 times 0x raised to the power of 0 minus 1. But since 0 is multiplying everything here, all that we have here is 0. So in this case, the derivative of this constant here is going to give us 0. So we can go on further by saying that this is going to give us, therefore, the y dx is equal to 6x raised to the power of 3 minus 1 is 2 plus 4 times 2 is going to give us 8. X raised to the power of 2 minus 1 is 1. X raised to the power of 1 is going to give us x raised to the power of 1 is going to give us x. Then we have it to be minus 3 times 1 times x raised to the power of minus x raised to the power of 1 minus 1. So we have it to be minus 3x raised to the power of 0 plus 0 is going to give us that. So in this case now, remember that x raised to the power of 0 is 1. So 1 times 3 is going to give us, 1 times minus 3 is going to give us minus 3. So in all of this, it means that the answer to this is going to give us just minus 3. So the derivative of this given expression is 6x squared plus 8x minus 3. So what you should take home from this right now is that whenever we are differentiating a constant without a variable attached to it, it is 4. And whenever you are differentiating a number times a variable, it is going to give us that number. So let's say you have 40 to differentiate. Y is a function of 40. So the derivative of y, which is a function of t, is going to give us 4. That is just a simple analogy to that. So thank you very much.